Hello everyone, in this video let's solve 2025 AB Precalculus free response question number 4. A function g and h are given by this guy. Solve g of s equal 4 for value of s in the domain of g. Alright, so we let this one equals 4, right? So 2 log base 3 of s equals 4. Alright, first we need to find the domain of the function g. S always greater than 0. Remember, log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0. Right? Now, you need to divide both sides by 2, so log base 3 of s equals 2. And you draw the arrow. So you have s equals 3 squared. S equals 9. Now, since s equals 9 greater than 0, so this is a solution. Now let's move on to the next one. Solve for h of s equals 3 for s in the interval 0 to pi over 2. So keep that in mind. So 4 cosine square of s equals 3, right? 4 cosine square of s equals 3. Now we need to know the domain 0 pi over 2. Alright, divide both sides by 4, so cosine square of s equals 3 over 4, right? Check square root both sides, so cosine s equals plus and minus root 3 over 2, right? Now, we have two different cases. Cosine s equals root 3 over 2, and cosine s equals negative root 3 over 2. Alright, so cosine s equals root 3 over 2, which means s equals pi over 6. And cosine s equals negative root 3 over 2, which means s equals 5 pi over 6. Now we look at the domain right here. S between 0 to pi over 2, which means your solution should be in the first quadrant only, right? So we just ignore this guy right here, right? So this one is not a solution. Right, so we need to solve this one. So s equals pi over 6, and that's it. Now let's move on to question B. The function j and k are given by k of s equal this one, k of s equal this one. Rewrite j of s as a single logarithm base 2 without negative exponent in any part of the expression. Your result should be of the form log base 2 of expression. Alright, so I have j of s equal to log base 2 of s plus 3 log base 2 of 2, right? Now, we have the formula log base a of b raised to the power of k. You can bring k to the front. So it's going to be k log base a of b. Now you can bring k back over here to get this one right here, right? So in order to condense this one, make sure coefficient in front of log should be 1. Keep that in mind. So I need to bring 3 back over here. So I have log base 2 of s plus log base 2 of 2 power of 3 equals 8, right? Now, since this guy have the same base, I have the formula log base a of b plus log base a of c equal log base a of b times c. So the answer must be log base 2 of 8 times s, and this is the final answer. Now let's move on to question 2i. Rewrite k of s as an expression in which tangent s appears exactly once and no other trigonometric function involved. Alright, so k of s equals 6 over tangent s times cosecant square of s minus 1. Alright, so we know that 1 plus cotangent square of s equals cosecant square of s, right? Now I need to subtract 1 both sides, so I have cotangent square of s equal cosecant square of s minus 1, right? So I just replace this guy right here with this guy, right? So I have set over tangent S times cotangent square of S, right? Now I know that cotangent S equals 1 over tangent S, right? So it turns out to be set over tangent S times 1 over tangent square of S, right? Now I need to simplify this guy and this guy. So I have set over 1 over tangent S, right? Now I need to multiply the top and bottom by tangent S to simplify this one, right? So this one cancel out. I have set tangent S, and this is the final answer. Now let's move on to question C. The function m is given by m of s equals e to the 2s minus e to the s minus 12. Find all input values in the domain of m that yield an output value of 0, right? So have m of s equals this one. Now I need to solve this one, right? So have m of s equals 0, right? Which means e to the 2s minus e to the s minus 12 equals 0, right? Alright, so in order to solve this one, we're going to use u substitution, right? So I'm going to let u be e to the s. Now the domain should be u greater than 0 since e to the s greater than 0, right? So I substitute u for e to the s into this equation. So I have u squared minus u minus 12 equals 0, right? Now I need to factor this guy, right? So I need to use S method to factor this one. I need to put C right here, which means negative 12, and B right here, which means negative 1, right? I need to find two integers multiply equals negative 12 add up to negative 1, which means negative 4 and 3, right? So this guy becomes u minus 4 times u plus 3 equals 0, right? So this one is the 0 product, right? So u minus 4 equals 0 and u plus 3 equals 0, right? So you need to solve for u. So u equals 4 and u equals negative 3, right? Look at the domain right here. U must be greater than 0, right? So this is not a solution because negative 3 less than 0, right? So this one is solution. So then you have e to the s equals 4, right? Because you need to substitute back over here, right? Now look at the base right here, the base e, right? So I need to take natural log both sides, right? So natural log of e to the s equals natural log of 4, right? Now I bring s to the front, right? So s natural log of e equals natural log of 4, right? Natural log of e equals 1, right? So s equals natural log of 4. This is the final solution. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand